everybody, I'm Roman Rodriguez and we are doing physics, grade 9 and 10. And we are on chapter 6, equilibrium, and today I'll be solving the last problem of this chapter, which is in your textbook. Problem on page 107, question number 7, 6.7 that is. Okay, so let's begin. Find the tension in the cable and the components of the force exerted on the beam by the wall in this figure. Now there are two components, horizontal and vertical component. Let's say H is your horizontal component exerted on the beam, okay? Exerted on beam, and V is your vertical component exerted on beam. Now, the weight of the beam is 300 Newton. Now, the weight of the beam is 300 Newton. So, let's say from here to here it is 5 meter and then it is extended over here 1 meter. So, that means total 6 meters. So, here's the length of the beam. This is the beam. And the length of the beam is 6 meter. So, the weight will be exactly the center. That is the distance from here to here is 6. So, we'll take 3. Let's say this is 3 meters over here in the center, and the weight of the beam is 300 newtons. So 300 newton, and this distance is 3 meters. Okay, and here also from here to here you have 3 meters. So the total length of the beam is 6 meters. Okay, 5 plus 1, 6. Right. So we have H is the horizontal component exerted on the beam, and V is the vertical component of the beam. We need to find these two, and also you need to find the tension T. Okay, T is equals to how much? So let's begin. So let's apply the first condition of equilibrium, where you know that according to the first condition of equilibrium, the summation of all forces acting along x-axis is equal to 0. And the summation for all forces acting along y-axis is also 0. So over here we will look at it this way, that horizontal minus Tx. Okay, we call this then Tx, and this from here to here is Ty. Okay, there you are. This equals to 0. This is the first equation. Now we also know that vertical component, the total force acting along y-axis is also equal to 0. This is again according to the first condition of equilibrium. So here the vertical component is V plus this V dy is equals to the weight acting downward, because acting in the vertical direction, that is 300 plus 300. So we'll get V plus Ty, 300 plus 300, 600. Let's move it on the other side, minus 600 equals to 0. This is our second equation. Okay, so we've worked it out for the first condition of equilibrium. Now how about working out for the second condition of equilibrium? In second condition of equilibrium, we know that tau is equals to 0. Tau or torque is equals to force into displacement. Now over here, counterclockwise and anti-clockwise, let's look at it from downward over here. That the force over here is 300 Newton. And the displacement from here to here is 3 meters. So we have 300 times 3 plus another force you can see over here. From here to here is 6, because towards the end of the beam over here is 6 meters. 5 plus 1, and here we have 300 newtons. So we have 300 times 6. 300 times 6. We are looking at it vertically. Okay, the torque. Now over here it is suspended at a distance of 5 meters. So we say this tension Ty times 5 will give you 5 Ty. Right, so this will give you 900 plus 1800 equals to 5 Ty. This and this will give you 2700 upon 5 is equals to Ty. Or we can say that Ty is equals to 5 5s are 25, 26 5 4s are 20, 540 Newton. So we've got Ty equals to 540 Newton. Okay, let's call this equation number 4. Now, let's apply it on this equation, number 2, and substitute the value of Ty in the second equation. We'll get the vertical component, that is V plus Ty is equals to 540 minus 600 equals to 0. So V is equals to 600 minus 540. So the vertical component is 60 Newton. There you are. The vertical component is 60 Newton. We just calculated this. Okay. Now, in order to calculate the horizontal component Tx, let's solve this using trigonometry. Okay. The triangle, let's call this O and this as point A and this B. So using trigonometry, I'm solving triangle OAB. And you know that Tx is equals to T cos theta and Ty is equals to T sin theta. Okay? So, Tx, we don't know. We know the value of the angle. It's making us 30 degrees over here. Theta is 30 degrees. So, Tx is equals to T cos 30 degrees. And Tx is equals to cos 30 is 0.866 times T, and Ty is equals to T sin 30 degrees, and sin 30 degrees is half, so we'll get T upon 2. Okay, so we have Tx over here and Ty over here. Now we know the value of Ty, which is 540, so let's put the value of Ty over here from equation 4. In this equation, let's call this equation 5 and this as equation 6. So equation 6 would now be Ty, we know is 540 is equals to T upon 2, cross multiply, so we'll get tension is equals to 2 5s are 10. So there you are, tension is 1080 and vertical component we got. Now we know T, we can calculate this Tx. Tx is equals to 0.866 times T. Tx is equals to 0.866 times T is 1080. It should be as well 1, 2, 3, 1, 2, 3, 0, 0 cancel. So you have 108 times 866. 6 8s are 48, 6 0s 0 4, 6 1s are 6, 8 4 6 again, 8 8s are 64, 8 0s are 0 6, 8 1s are 8. So you have 8, 4 and 8 is 12, 6 and 4 10, 14 and 1 15, 6 and 6 12 and 1 13, 8 and 1 9. So Tx is equals to 9352 upon 100. Which means Tx is equals to 935.28. Let me shift this decimal 1 2 places over here. Newton, and you know that Tx is equals to H, right? Here you can see in equation number 1, we have H minus Tx is equals to 0. So H is equals to Tx, so your horizontal component is equals to 935.28 Newton. There you are. So I've just calculated the horizontal component, which is 935.28 Newton. The vertical component exerted on the beam is 60 Newton, and the tension on this cable, as you can see over here, is 1080 Newton. Right? So I hope it is clear to you all. And with this we complete this chapter. Take care.